People often ask me what's involved with a heat pump service. So today we're going to service this 14 kilowatt EcoDan. This is quite an interesting install that we did about a year ago, maybe a bit longer. It's a period property in Plymouth. Had a lot of work done in terms of improving its insulation. We did a heating installation throughout, upgraded lots of radiators and pipe work, put in this 14 kilowatt heat pump. It's been running great since then. Client's happy with the temperature of the house. It's actually performing quite well as well, so we'll look into that later on. It's actually got an open energy monitor, which will tell us exactly how much the heat pump's using, so we'll be able to adjust some of the settings later on and see if we can get some better performance out of it as well. So the reason we clean the coils is because as the air is passing past the coils and transferring the heat into the refrigerant, if there's a layer on the outside, like an algae build up, or here even a bit of kind of a diesel sooty kind of build up because we're near a main road, this can reduce the efficiency of the heat pump. So we've cleaned that, and the cleaner's quite good at cleaning the outside as well, so we give it a little bit of a clean as well. Just one more task to do outside, and that's check the pressure reducing valve inside the heat pump. So this is actually a safety valve to make sure that the pressure in the heating circuit doesn't get too high. It's outside on these units because it has R32 refrigerant in it, which is essentially propane. So it's quite flammable. So if there was any kind of break in the refrigerant circuit inside, say, the heat exchanger, that would allow the refrigerant to go into the heating circuit, the first place it's going to come out is in here, not in your house. So this is the valve here. So just have to check that it's working properly, which it is. Now it's reseated properly. Yeah, that's fine. I'll quick pull test the connections here. They're all good. And that's it, and put it back. So now we've done everything we need to on the outside unit. We'll go in and look at the cylinder, service the cylinder, and have a look through the energy monitoring and see how well it's been running, and make any adjustments we need. When we arrived at the property, we had a quick chat with the customer just to check that the heat pump had been working as expected throughout the year, and that the heat throughout the property was well distributed. We also did a visual inspection of all the components to look for any obvious wear and tear or damage. So as you can see, quite a beast of a cylinder in this cylinder cupboard. So it's 400 litres. There's quite a lot of bathrooms in this property, so it did really need it. We've got a buffer tank here, but it's actually not being used as a buffer tank before I get slain by people in the comments. It's a volumizer, so it's just to add a bit more volume for when maybe just the towel rails or some of the radiators are running. This is a heat meter. That's for the emonPi heat metering setup. A large pump on this one. You need to get really good flow rate for all the radiators. I think there's over 30 radiators in this property. So to get the good flow rate on every floor, across all 4 floors, we've got that beast. And yeah, that's about it really. So I'm going to crack on with the service, check the safety valves, check the expansion vessels. So once we've taken this out of the filter, just have a good look through it, make sure there's nothing massively corroded and chunks of stuff in there. It's actually pretty clean, as you'd expect from the first year. It's blue because it's got glycol in it, which is like an antifreeze. It's just in there to protect the system if it ends up freezing outside. We need to check that every year, so we're going to go outside now and check that with a refractometer to see what temperature it can go down to without freezing. So just to check the antifreeze is adequate in the system, we put a little sample of it on the end of the refractometer here. There we go. Flip that one over. When we look up through the refractometer, we can see how far it's protected to, and it's down to minus 11. So that's all good to go. So just depressurize the cylinder, and this water expansion vessel needs checking. So just check that. And that's a bit low, just under 3. So I'm going to top that up a bit. It's just a normal bike pump, just with a longer hose on it. So now we just have to check the expansion valve, temperature and pressure relief valve on the side of the cylinder here. That's all working. And that's reseated itself properly. And there'll be one more, yeah, over here. The incoming supply. Yeah, that's working fine. Just top this pressure up a bit. So we bleed radiators because otherwise an air pocket can form in the top of the radiator. So as the water's flowing through, only some of the radiator's heating up, so it reduces the heat output. So it's a good check on the service just to make sure there's no air trapped anywhere. So as you can see, some of these radiators end up being quite big in properties like this where we don't have quite high levels of insulation. So this is quite a big hallway. Old wooden door, so it's a bit draftier, so it needs a really big radiator. But I think in all, it kind of blends in, it doesn't look too bad. It's kind of white like the rest of it, so you don't really notice it. So this property, having single glazed windows, is listed, so it has to, and not a huge amount of insulation in the walls. I think there is a very small amount of insulation on the internal side of this wall. The radiators end up being quite large. This vertical option means we can get a lot of radiator in for the amount of wall space that it takes up. So we've had to put in 2 of those in this room. And then further into this, it sort of opens up to a living room here. There's another 2 radiators there. But it shows that it can be done, low temperature heating systems, in single glazed windows with, you know, very, very little insulation in the wall. You still get high efficiency output. So as there's a bit of air in the top radiators, we now have to top up the pressure a bit to replace the volume that's just been lost through the air coming out. Just checking out the stats, and it's looking really good. It's like it's running really well. So you can see on this heat meter here, it's generated 24,000 kilowatt hours, 24,122. That's for hot water and heating. So it comes in from the heat pump before it diverts off to the heating or goes into the cylinder. We have 2 electrical meters in here, one on the controls for the heat pump and one on the actual heat pump. So if I add those up, I'm not married to phone now. So if we just add these up, so that's the controller there and that's the heat pump. It's got 165 plus, what's that, 5650. 5815 kilowatt hours of electric. That's a bit just over a year. And now let's look at the heat. So if we do 24122 divided by 5815, that gives us a coefficient of performance of 4.14, which is really great for a property of this size, the level of insulation that it's got, and the fact that it's a larger 14 kilowatt heat pump. Having the emonPi is so useful. On this job we can look back through the year, see how it's been running, and then we can change settings on the heat pump to sort of fine tune that efficiency and try and get the heat pump running at the absolute optimum performance. So you can look at this install on the top of the COPS heat pump energy monitor.org website. So this is a chance for all the users of the emonPi to publish their data publicly. So we are listed under here. You can see us under Reco Energy here. And also just to show you what's running like. So unfortunately we did have some data loss from the internet, not being connected for a while. But as you can see, throughout the month, it's had a COP of about 4.05. You can go on and look at this live on the link in the description. If you'd like more information on the servicing or installation of heat pumps, or maybe even the energy monitoring side of things, please get in touch. Our website is in the description. And if you like more of this kind of content, please like and subscribe.